The next method for solving quadratic equations that we need to explore is called completing the square. Now, when we convert a quadratic equation to a perfect binomial square and then solve that resulting equation using the square root method, we call this procedure completing the square. So to get us started, let's consider the quadratic equation ax squared plus bx plus c is equal to 0, where a, b, and c are all real numbers, and of course, our leading coefficient a cannot be equal to 0. So the first thing that we need to do here is to isolate the constant term on one side of the equation. So in order to isolate this constant c, we're going to subtract it from both sides. So now that we have the terms with variables on the left-hand side and the constant on the right-hand side, we can proceed to step 2. Now, if the leading coefficient of the quadratic equation you're working with does not equal 1, then we need to go ahead and divide both sides of the equation by that leading coefficient a to obtain a leading coefficient of 1. So looking up here at our given quadratic equation, since a is arbitrary, we cannot assume that it's equal to 1. So we're going to want to factor in a out of both terms and then divide by a. So now that we have factored out our common a and divided both sides by that leading coefficient a, we have obtained an easier quadratic form to create a perfect square. So to help us out here, let's recall the square or the general formula for the square of a binomial. So recalling the square of a binomial, we can observe here that our constant term, a squared, is in fact the square of half of the coefficient attached to the variable of degree 1, 2a. So let's just quickly confirm this. We can see that if we take that coefficient 2a and take half of it or divide it by 2 and then square this, what we're left with is a squared. So this is what we're going to need to complete the square on our standard quadratic equation. So again, to complete the square, we are going to add half of the coefficient attached to the variable of degree 1 squared to both sides of the equation. So looking back up here at step 2, here is the coefficient attached to the variable of degree 1. So this means that we can go ahead, and again, we're going to add half of this squared to both sides. So we're adding b by 2a squared to the left-hand side and the right-hand side. So notice we have the perfect square trinomial matching the formula up above, which allows us to rewrite this expression as x plus b over 2a squared is equal to minus c over a plus b by 2a squared. So we have achieved that perfect square, the square of a binomial, and now we're officially ready to take this and solve for x using the square root method. So there you have it. Here is the strategy to help us understand how and why we are completing this square.